Intermediate Mathematical Olympiad Cayley paper 2022 question 5. This is an example of the Pigeonhole Principle. If you want to Google it, there are some videos online. There's even its own Wikipedia page. Question 5. A ladybird is free to fly between the 1 times 1 cells of a 10 times 10 square grid. She may begin in any 1 times 1 cell of the grid. Every second she flies to a different 1 times 1 cell that she has not visited before. Find the smallest number of cells the ladybird must visit, including her starting cell, so that you can be certain that there is a 2 times 2 grid of adjacent cells, each of which she has visited. Now, the solution takes you through step by step, but I'm going to see if I can make it make any more sense than the formal solution with a poppet. So if we've got the ladybird and they're visiting 3, then they haven't quite completed the 2 by 2. So if we now go to here, well, this one isn't completed, but if we complete those 2, then here it could be either one of these. I'm going to keep the same pattern and close that one down so that we've got 3 here. This one here, we've got 3, 3. There we go. So in each of these 2 by 2 grids, we haven't got 4 of them that have been visited. Okay, so within those, that's the if we just looked at these, that's the maximum she can visit without having one lot of 2 by 2. And if we extend that to the next row, we would actually have these. So again, we still have, if you look at every 2 by 2 grid, we have only 3. And if we clicked on any one of these, we would then get 4. And there are lots of different combinations of these. You're welcome to have a go, shade in squares to be able to make it work. But what you do get is, if we follow that logic through, we have, it looks like this. Now, the way that the official solutions show it is that you've got a grid of 2 by 2, 2 by 2, where you've only ever got 3 ladybirds in each section. And that is the same as we've got here. The filled in are where she's visited, and the raised is where she hasn't visited yet. It's more difficult to show you those 2 by 2 grids, but it also does allow you to see the ones in between. So that's your 2 by 2 grid, but that's also a 2 by 2 grid. And this one here, 2 by 2 in here, there are no 2 by 2 grids on here. Now, if you count up all of the ones that aren't visited, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, we've got 25 that aren't visited. Therefore, we have 75 that are visited. So I can, the ladybird can visit 75 without having a 2 by 2 grid. All she does now is need to visit one of any of these. So that'll be the 76th. And the 76th will mean, let's do that in a different color than blue because it's difficult to see. How about this one here? Then you're definitely going to get at least 1. You can have a play, as I say, draw some sketches, draw them out, but you will discover that the 75 doesn't fulfill the criteria, but only 1 more will then fulfill that criteria. So the answer is actually 76. 76 is the smallest number of cells visited that guarantees a complete 2 by 2 grid somewhere. There is now a 2 by 2 grid here and here and here and here. But that is the solution.